Hello, my name is Chung On. Today I'm presenting for JAC 444 Workshop 9. Before I talk about my code, let's talk about the Levenshtein algorithm. So we have there's a source like this, computation, Levenshtein distance. So the distance could be like this, and then I found a related on the same website a related um, implementation of this. Well, not the same author, but I found something like this. So it's called calculate function. So so by substitution and so on, then we obtain the edit distance. So this is it. In my code, what happens is we are trying to find the edit distance, but the thing is, what I found was if you try to use the calculate function from this website over there, you're not getting the same as what you would do with any function about getting the intermediate words. What happens is the required output is this. So from dog to cat is just 3 because uh, you change the letters, so 3 letters, 1 letter at a time, so 3 times. From dog to rats, 5 times. But if you use calculate, then it ignores the intermediate words and returns 3. Why? Because from dog to rats, you just need to change 3 letters. You don't go through 5 words you don't go through 5 times, 1, 2, 3, 4, 5 to go to rats. It doesn't work like this. And in the test file, we just have these words. So if you go through 3 times, it doesn't make sense because you cannot just go through 3 letters and none of the changed letters are listed in this file. At most you have dots. You cannot from DOT to say ROT. There's no ROT here. There's no um there's no DUT here. So you must go through at least 5 words to reach rats, right? So same with the text file. So to test this, basically I can get the same output here from dog to cat, 3. From dog to rat, 5. Q isn't here. Enter, exit. I think it depends on how you see it because I cannot say it's wrong to go through each letter to so from dog to DOT ROT that's 3 times, right? But it's not the same as the text file. So I think ultimately we can just ignore this and just do the method by finding intermediate words. So these are intermediate words. And actually not even these two because from cat you can just go to rats without going through these 2 words. So we can skip 2 of them and we still need 5 steps. Let's call edit distance like 5 steps. It's the same. So in my code, what happens is after we set up the user input, so we have all this dictionary to read from the text file and then asking for 2 words. So we just need to see if the words match the dictionary words, and then we initialize a word list. So that is the start of it, dog to cat. So you have dog, and then there's a queue, and then we put the keywords into next word a string just to see the intermediate words. If we find nothing, then we say no path found. Basically, it's about when the words are of different lengths. So it 5-letter words or 4-letter words or any letter words as long as they are of the same length. Otherwise, there's no match. So we put it into another list and then display the output. And in the get intermediates, we count the intermediate words and print them. So to test this again, say if we use the bigger file, from dog to cat, that's 3. From dog to rat, also 3, because this file has different words, right? If we try words of different lengths, so say so no path found. But for same lengths, even for very different words, you can still find something like this. Short to break, that's 9. So they change one letter at a time. So I think overall, I know of the Levenshtein algorithm, but basically for the purpose of this workshop, I can just ignore that because it doesn't work this way. I I need to count the intermediate words within the text file. So that's how we have this output here, 5 instead of 3. Because for 3, so if you again, I must say again that if you use calculate function, so you can have, so from dog to rat, if we use the algorithm, then it's gonna be like this. That's 3. But if we refer back to the test file or dict file, we have something else. So just now in the dict file, a text file, we have different words, duck and rock. So it happens to be 3, but that's just because they have these words. Without these, probably it's gonna be no match, no path found. And in this file, we happen to have 5 words here. So it depends on what text file you're using. It's no longer about Levenshtein basically. But Levenshtein and intermediates, they are both valid ways of finding how many words does it take to reach word B from word A. Thank you.